Solving inequalities. There is a method. We start by doing PEMDAS, and in particular we're doing PEMDAS to the left and PEMDAS to the right. Then we continue by applying the properties of the equality, and in particular we apply the addition and subtraction properties of the inequality to cross the bridge, which are the same as the properties of the equality, meaning whatever you do to one side you do to the other side. You add the same number or you subtract the same number. And then we apply the multiplication and addition property of the inequality to isolate. Those are the same as for the equality, meaning whatever we multiply one side with or divide, we do the same for the other side. But when that number that we multiply or divide with is a negative number, then we have to flip the inequality, and that's the method. It's almost the same as the method that we used in solving equalities. Let's apply to this example. We have 3 minus 2 parenthesis 4x minus 2 closing parenthesis greater than or equal to 11 plus 4 parenthesis negative x. Usually it's gonna be written as negative x plus 1, and let's start by applying the first step, which is PEMDAS, in particular do PEMDAS to the left and PEMDAS to the right. Okay, PEMDAS, and I refer to the left. Do I have a parenthesis? Yes. Let's check inside the parenthesis and see if there is anything that I can do. Little PEMDAS inside the parenthesis. Do I have a parenthesis inside the parenthesis? No. Do I have exponent inside the parenthesis? No. Do I have a multiplication inside the parenthesis? Yes, 4 times x, but I don't know the x, so I can't do it. Do I have a division? No. Do I have addition, subtraction? Yes, but 4x and 2, they are not like terms, so I can't add or subtract. Therefore, going outside, looking at the outside PEMDAS that govern the whole right hand side, there's nothing to do when it comes to the parenthesis. I move on to the next letter. Do I have an exponent? No. Do I have a multiplication? Yes. So this is what I'll do, and there is certainly something to do here. I multiply a number times a parenthesis. That means I will distribute the number among the terms of the parenthesis. Now there are two terms here, 4x and negative 2. In general, terms are connected by a plus or a minus. You can't say that 4 is one term, x is another term, and negative 2 and a third term. 4x is one term because it's 4 times x. Multiplication, when two numbers are multiplied, or a number and a letter or two letters, they're still the same term. Okay, so those two, the 4 and the x, because they are connected by a multiplication, they are the same term. So don't put the third arrow, one for the 4, one for the x, one for the 2. Okay, so let's see what happens now. The 3 is gonna drop, and I have negative 2 times 4. Negative times a positive. The 4 has a hidden positive sign. Have negative times a positive is negative. 2 times 4 is 8, and the x follows. Then negative 2 times negative 2. Negative times a negative is a positive. 2 times 2 is 4. So I have 3 minus 8x plus 4 applying PEMDAS to the left. The sign is going to drop. Let's see what happens, what I'm going to put there. I'll see what happens after I apply PEMDAS to the right. So let's write PEMDAS here. That will govern the right hand side. Parentheses. I do have parentheses here, so I'm gonna go inside this parenthesis and I will apply another little PEMDAS. Do I have a parenthesis inside the parenthesis? No. Exponent? No. Multiplication? No. Division? No. Addition, subtraction? Yes, but x and numbers cannot be added or subtracted. They are not like terms, so I don't have addition, subtraction. Therefore, on the right I can't do parentheses. Can I do exponents? Are there any exponents? No. Multiplication? Yes. It's 4 times a parenthesis. That can be done. So I will do the multiplication on the right. Let's do the multiplication. Multiplication, since it's a number times a parenthesis, I will distribute the number among the terms of the parenthesis. There are 2 terms, negative x and plus 1. Okay, now 11 drops, and I have plus 4 times minus x. Here this minus really means minus 1 times x. So essentially I have to multiply plus 4 times minus 1. Okay, positive times a negative. First the signs, that's a negative. 4 times 1 is 4, and the x follows. Then plus 4 times plus 1. Positive times a positive is a positive. 4 times 1 is a 4. And that's it for starters. Now I will continue, starting again from the left, and see if there is any more PEMDAS to do. So I will apply another PEMDAS on the left. When there is a new line, we put a new PEMDAS. Okay, do I have a parenthesis? No. Exponents? No. Multiplication? Yes, over here, 8 times x, but I don't know what x is, so I can't do it. So no multiplication, no division. Addition, subtraction? Yes, I have both addition, subtraction. Now, can I subtract those two? No, they're not like terms. How about those two? No, they're not like terms. How about those two? Yes, those are both constant terms, and I can subtract them, and this is what I'm going to do. So what I'll do here is addition and subtraction. Okay, let's do that. Let's do this. 3 plus 4, they're both positive. We just add them, we get a 7. The negative 8x drops, and we go to the other side. The sign drops, and let's do a PEMDAS on the other side. Do I have parentheses on the right? No. Exponents? No. Multiplication? Yes. Negative 4 times x, but I don't know what x is, so I can't do it. Division? No. Addition, subtraction? Yes. There's addition, subtraction. Let's see if I can do any of those. Can I add or subtract 11 and 4x? No, they're not like terms. Can I add or subtract negative 4x and 4? No, they're not like terms. Can I add or subtract 11 and 4? Yes, actually I add them. Yes, I can add because they're like terms. So there is addition or subtraction, and this is what I'll do. Now what is 11 plus 4? That's 15. And negative 4x drops. Okay, so now I got a new line. To continue, I need to apply a new PEMDAS to the left and then a new PEMDAS to the right. Let's apply a new PEMDAS to the left. Do I have a parenthesis? No. Exponents? No. Multiplication? Yes. 8 times x, but I don't know x, so I can't do it. Division? No. Addition, subtraction? Yes, but 7 and negative 8x are not like terms, so I can't do addition or subtraction. That means there's nothing else to do on the left. I'm done for the left hand side. Let's go on the right now. Again, it's a new PEMDAS, a new line, new PEMDAS. Do I have parentheses on the right? No. Exponents? No. Multiplication? Yes, 4x. But I can't do it because I don't know x. So no multiplication, no division. Addition, subtraction? Yes. But 15 and negative 4x are not like terms, so they don't mix. There's nothing to do on the right. That means I have completed PEMDAS to the left and PEMDAS to the right. The next step is the properties of the inequality, starting with addition and subtraction to cross the bridge. Terms need to cross the bridge and find their relative terms. And in particular, for starters, I want all the x on one side and all the numbers on the other side, and then I will, after I do this, I will isolate. Okay, now looking at how I'm going to cross the bridge, and let's decide what side will take the x. If I decide that the left side is going to take the x, negative 4x needs to go to the left. If I decide that the right hand side is going to take the x, then negative 8x will have to go to the right. So crossing the bridge, left to right or right to left, depends on what I choose. There is no one correct choice and the other is wrong. They're both correct. So here I will choose that the x terms are going to settle on the left. So I'm going to bring the negative 4x to the left. How I'm going to do that though? I'll have to use those properties of the inequality, which are the same as the properties of the equality. First I need to eliminate the negative 4x from the right. I do that by adding the opposite, and the opposite here is a positive 4x. But because those are properties of the inequality or the inequality, I have to do the same on the left hand side. So those will be eliminated, but then I will have a 4x to be combined to the negative 8x on the left. Can 4x be combined to 7? No, because they are not like terms. Okay, so what do I get? 7 drops. Negative 8x and 4x will be combined and give me a negative 4x. How did I do that? How did I find this negative 4? Let's go back a step. I have negative 8 and plus 4. Those have opposite sign. I will have to subtract. So I will subtract 8 minus 4. 8 minus 4 is going to give me 4. But what is the sign? It's going to be the sign of the greater number, which is 8. Its sign is going to dominate and remain, and that's going to make it a negative 4. The x follows. Okay. Do I need to flip the inequality? No, not for addition or subtraction. So the inequality follows. And what happens on the right? 15 drops. And those have cancelled each other and they give me 0, so I don't write anything. Okay. Now let's see what we got here. I have put all the x on this side. That means the numbers go on the other side. So the shortest thing to do is to move the 7 to the 15. That saves us a step in comparison to if I move the 15 to 7, combine them, and then move all of it back. We'll just do in one step. 7 moves to the side of the 15, then all the numbers will be on the right, all the x on the left. How do I do that? Properties of the inequality or properties of the equality are the same. They are telling me you have to eliminate the 7 by subtracting 7, but then you have to do that on the other side. So I subtract -7 on the left as well. 7 minus 7 is 0. I don't write anything. -4x drops. How about the inequality? Will it flip? It's a negative number. No, not for addition or subtraction. It's not going to flip. Then we'll have 15 minus 7. Obviously it's 8, but if you want to follow the method of adding or subtracting, they have different sign. One is positive, one is negative. You subtract them. 15 minus 7 is 8, and you put the sign of the greatest one, which is 15, and it's positive. So it's plus 8. Okay. Now, is there any other term to move across the bridge? No. So we have completed that part using addition and subtraction properties of the inequality or equality to cross the bridge. Here we have both an inequality and an equality. So, but we're lucky because that it's the same properties when it comes to addition and subtraction. Here, though, we may have to do something that's particular to inequalities. All right, we cross the bridge. Now we need to isolate the x. Therefore, how do I do that? The -4 needs to go. So let's rewrite this here. -4x and 8. How do I make the -4 go? No matter if it's an inequality or an equality, I do the same. I divide by -4. I divide by whatever is in front of x. That's the coefficient of the unknown x. Okay, I divide by -4. No matter if it's an inequality or an equality, I divide by -4 the other side as well. For the equality, nothing changes. But when it's an inequality, the moment I divide by a negative number, it needs to flip. So it's not greater than anymore, it's less than. And that's the only difference. And I do that because I divide. I would do the same if I multiplied by a negative number. If I divided by a positive number or multiplied by a positive number, the inequality will not flip. Okay, so here's where I'm at now. What do I do? First of all, I will divide -4 by -4, which is 1, and then times x. So -4 over -4 is replaced by 1, and what's left, this x is multiplied, less than or equal. Now let's see how will I divide 8 over -4. 8 is positive. Positive over a negative, I get a negative. 8 divided by 4, I get a 2. And last step, 1 times x, I will just write it as x, less than or equal to -2. That is my solution. Now, if I want to write it officially, I will write it as a set solution and use the braces to indicate what it is, but I'll save it for the end. For now, based on this inequality, I will write I will write the graph solution. To write the graph solution, what you need is the number line or real line. It's a line that you can put all real numbers starting from negative infinity all the way to infinity. The important number is negative 2. X can be equal to negative 2, so I put a solid dot to indicate that. If it could not be equal, if that was missing, I would put a circle to indicate that this number is missing. There is a hole there. There is a number missing in the number line. But here it can't be equal, so I will emphasize with a solid dot. And then x is less than negative 2. That means it's to the left. And here is where all the x solutions, the solutions that the numbers that satisfy my equation are located. For example, negative 3 is here, negative 4, negative 3.5, anything, any number. There are infinite numbers that you can plug in and satisfy the solution. What satisfy means? That means if you plug in any of those numbers, you get a true statement. What happens if you plug in any of the other numbers that are here? For example, negative 1, 0, 1, 2, 2.3, 2.3, 1, 1, 2, 3, 1000. What happens? What happens is that if you plug in any of those numbers that are to the right of negative 2, you'll get a false statement. Okay, so here is the graph solution. Now, let's write this inequality as a solution. How do we do that? That would be called the set solution. The set solution will be inside braces. This is the standard way of expressing a set. And I look at the graph solution, or I look at this one, and I see that x, all the x are between negative infinity and negative 2. In particular, there are less than or equal to negative 2. That I can see also from the inequality that I found. And they are greater than negative infinity, because you can never have equal to infinity. And this is the set solution. Sometimes that we can just write it as x less than or equal to negative 2. Since anything really is greater than negative infinity, that doesn't add new information, but it's good to have. It's good to have there anyway. And then we have the interval solution. Let's put it underneath. That only takes into account the endpoints. The endpoints are negative infinity and negative 2. Either you can see it either in the graph or in the set solution. So I write negative infinity, comma, the other endpoint, which is negative 2. If you can include that endpoint in your solution, you put a parenthesis. You put a bracket. If you cannot, you put a parenthesis. So parenthesis means exclude. Oops. Bracket means include. Now, can we include infinity? We can't. We can never reach infinity. We emphasize, you can see that here emphasize that because there is no equal. So it takes the parenthesis. We can't include infinity to anything. How about negative 2? Well, negative 2, it can be included, can be equal to negative 2. And here I see there is a solid dot. Maybe I should just emphasize here that solid dot means include, and circle means exclude, just to have everything. But I see that negative 2 can be included, so I will just use a bracket, and this is the interval solution. So this is all the solutions. Now, how can I double check? How can I check that what I found is correct? Like what I have found here expressed either as a graph solution, set solution, or interval solution is correct. I will have to confirm my solution. That's in the next video.